Hi and welcome to a new Voltlog. Today we are building a soldering iron kit. In this case it's the Hakko T12 compatible soldering station. All the parts were offered for free by Banggood, but if you are considering buying all the parts shown here, the total cost will be around $42 with free shipping calculated at the time of this video. And there will be links in the description for all the items shown in the video. After completing the assembly, we will also be doing a comparison with my OLED STM32 soldering station that I got recently. So in terms of parts, the enclosure is very similar to my other station. In fact, it's exactly the same dimensions and model. The enclosure comes with the front and back panel already drilled and seal screened, which is very nice. On the back you get a 3-pin mains input socket and a separate rocker switch, but no fuse socket has been provisioned on the back. I also got this stand, which comes as a separate product, but you need a stand for resting the soldering iron, so I suggest you get one of these. This is the actual soldering iron kit. Let's see what they have included here. So we get the handle, some multi-way cable, we get a T12 chisel type, or no, this is a knife type tip. This is the T12K. Inside here we have the actual control PCB, some connectors, some wires, some heat shrink, basically all you need to complete this kit. I suggest you get yourself a few different tips, different models, because they are inexpensive and will make individual soldering jobs easier, because when soldering there is no one size fits all. And this is the power supply that we'll be using. It is a 24 volts 4 amp capable power supply. It looks to be half decent. It has 1 hang low capacitors installed, but it seems to have the required protection and filtering elements installed. It's got a fuse, X-rated cap, input filtering choke. This is a thermistor, an NTC thermistor. The transistor doesn't seem to have double insulated wires like we saw on the OLED soldering stations that we tore down in a previous video. So not the same quality transformer. And I must say this power supply has that nasty chemical smell that you get on some of these products coming from China. I'm not sure, but the smell might be coming from the transformer. Regarding the capacitors, you could replace these with something of higher quality. On the input we have 82 microfarads 400 volts, and on the output we have 1000 microfarads 35 volts. So now we're ready to start the assembly. First thing I want to check is how the power supply will fit inside and how I'm going to mount it. The power supply is too long to be installed like this and use the rails on the side of the enclosure, and too short when it's installed in this position so it doesn't reach the rails on the side. We need to figure out another mounting method. So I have the front and back panel in place just to check the clearance, and it looks like I could fit the power supply like this in the middle of the enclosure, and it will have enough clearance on all sides for the front and back panel to be installed. I will be using these 4 brass M3 standoffs to mount the power supply board on the bottom of the enclosure. These are M3 6mm standoffs, and I have checked for clearance on the height of the enclosure, and the heat sinks do not touch the top of the enclosure. I will also drill a 5th hole somewhere in this region close to the back panel. and that will be used for the earth connection. So I need to drill these 5 holes. I'll be right back. This is how the enclosure looks like after I've drilled the holes. You can see here for the earth connection, I have tried to scrape away the paint just to ensure better electrical connections. Now that I have these holes drilled, I can install the power supply, and for safety reasons I recommend you insulate the bottom of the PCB from the bottom of the aluminium enclosure. You can use any insulating material. In my case, I had this thick 0.3mm paper, which should do the job just nicely. As you can see, I used a template. I did these cutouts for the mounting holes, so this should fit in here like this. I will also use some insulating paper on the top side of the enclosure, because I don't want these heat sinks accidentally touching the top of the enclosure. One of these heat sinks might be at live potential, and that is dangerous. So I suggest you also insulate the top of your enclosure. Next, I'm going to wire the mains input socket and the on-off switch, just to finish the power supply stuff so I can test it. Theoretically, you should be switching the line or the hot wire, and I believe with this type of socket is this pin right here on the right, and indeed if we look closely it is marked line on the plastic shell. So that is the pin that you should run through the switch. For the earth pin, I have created this small cable with a crimp connector, and this will go between the earth pin and the metal chassis, and it will be connected with a nut and shake proof washer. This is important for safety reasons. Do not skip this step. This cable is not included in the kit. I have created it myself. Before going any further, I would like to test that this power supply is working. So I have an AC plug right here. Let's turn the power supply on, and I can see a very faint green LED, so it's probably working. Let's check the voltage. I'm seeing 23.9 volts. So yeah, the power supply is working. Now we can continue. I will continue by assembling the front panel, and we need to start with this handle connector. This has its own lock nut, and it needs to go in like this through the front with the plastic washer and the lock nut, and it needs to be aligned somewhat with this notch facing the top side, something like this. Before putting everything together, don't forget to also insert the LED. Make sure you get the polarity right, but don't solder it just yet. And now push the LED until it comes through the front panel, and that's the final position where you need to solder the LED in. Unfortunately, in my case, the 7-segment display was not perfectly aligned when soldered on the PCB. So as you can see, it looks just a bit of axis on the front panel, but there's nothing I can do about that. It's very difficult to desolder one of these multi-pin 7-segment display. I'll probably destroy it in the process, so I won't try to do that. Now let's do the soldering, and I will start with the handle connector. You need to put a bit of force on the PCB when soldering, just to ensure everything is level. Make sure you haven't created any shorts between these pins, because that could mean trouble, for example shorting the positive and the negative together. One thing they forgot to do with this controller board, and I find it very important, is they forgot to connect the earth pin that goes to the actual handle to the earth of the enclosure of this PCB. But we can fix that easily. We have earth present on the front panel. It comes through the body of the enclosure. Then it goes through the body of the potentiometer to these two mounting points, and if we solder a wire from one of these mounting points to the earth pin, we will have an earth connection going through the handle. This is how I've done it. So now we have an earth connection going to the handle as well. This is important to make this soldering station ESD safe. As long as the handle is grounded and the shield of the soldering tip is grounded, any job you will do will be ESD safe. The wires that came with this kit are 24 AWG, and I find that kind of insufficient for the 24 volts 4 amps that this power supply will be switching to the heating element. So instead I will replace these with some thicker cables. Let's check. These are 18 AWG. So these are more likely to handle the like I said, 24 volts and 4 amps. Next I will wire the handle connector, and by the way, the cable provided, it's very nice silicone type. It's, I would say, of the same quality to the one I reviewed in the STM32 soldering station controller. So that's a very nice thing. And I will start by inserting this metal jacket on the cable. I will insert the plug into the front panel just to get the wiring right. And don't worry, there will be a wiring diagram in the description below. You need to start by stripping about this much cable, so we are now free to solder these wires to the connector. Although this connector has these separators between each individual pin, I think I also have room to install a small piece of heat shrink on each of these pins after soldering, just to ensure they never short inside the connector. So now next I'm going to solder the wires to the connector. So this is the color code I decided to use on this connector, and it kind of makes sense. We have green for the earth connection, we have black and red for the negative and positive connection, and blue for the A point connection, B for the B point connection, that being the switch. Apparently I removed too much of the insulating jacket, so I need to fix that with another piece of heat shrink, because right now when I come with this metal jacket, it needs to grab the cable with this clamp right here. Now to continue with the handle assembly, we need to install this small vibration switch. This needs to go in here. Next, don't forget to pass the cable through the handle, because you won't be able to do that later. This time I took away less from the insulation, and it seems like you have two options for soldering. You can use either the holes or these pads. I think I will use the pads and solder the wires like that, and then we can use one of the provided zip ties to ensure this cable does not get pulled from the solder joints. As I was thinning these wires, I was thinking the T12 tips are 70 watt rated tips, and I used the nice thick wires to bring power to the control board, but just look at these thin wires they're using from the controller to the handle. These are maybe AWG26, I'm not sure, maybe they are thinner than that. So I'm not sure how these a pair of these would carry 70 watts to the tip. I'm pretty sure there is a serious voltage drop on these wires. I've used one of the supplied zip ties to secure the cable to the PCB. So now we can insert this assembly inside the handle. I will also install the supplied tip. Before connecting the handle, I need to finish the control unit. I need to connect the power supply to the controller board. Make sure you get the polarity right. I will also install the cover just in case something goes wrong. So let's apply power and test it without the handle connected and see what we get. So I'm seeing 500 displayed on the screen. Let's set it for a modest 100 degrees Celsius. I'm not sure if 500 means anything. I would have liked it to detect that it has no handle connected. But anyway, let's try connecting the handle. So I turn the power off just in case something goes horribly wrong. I'll place the handle into the stand. So let's turn it on. The LED is blinking. Is it blinking in accordance with the heating element being turned on? Maybe. Yeah, I think so. So I think the LED is signaling when there is current applied to the heating element. Let's try increasing the temperature slowly. Some users commented in the past on my mailbag videos and told me that these tips should be slowly brought up to temperature to avoid a sudden thermal shock. So don't just go on 300 or 400 degrees Celsius. Slowly bring up the temperature so there is less thermal stress on the first heat up of the tip. Let's do a quick temperature accuracy check. So the station is set for 250 degrees. Let's see what the thermometer is saying. Wow, we are well above 250 degrees. We are at 320. Let's see if we can somehow use the calibration pot to adjust that. Okay, so we are now closer. We are now measuring temperature closer. After adjusting that calibration pot, we are seeing 250 degrees on the station and 250 degrees on the thermometer. So it's better now. As mentioned in the beginning of this clip, I would like to compare the time it takes this station to reach 280 degrees Celsius from room temperature with the time I measured for the STM32 station that I reviewed last week. So let's start. I think we are at room temperature right now. Yeah, about 30 degrees on the soldering iron tip. So I'm going to start the station and see how fast we reach 280 degrees. We can see the heating element is fully on. Well, it shows it reached 280 degrees on the display, but it takes a little bit longer to reach it on the tip. Now I'll give you my final thoughts on this soldering station kit. It was pretty easy and fun to assemble, and there were no missing parts. The heating time or the heating performance, I don't know how to call it, is similar to what I've got on the STM32 station, around 16 seconds to get from cold to 280 degrees Celsius. This leads me to believe the two different T12 tips that I used for testing each unit They were the same model, but one of them came from Banggood, the other one came from the Taobao seller. So as I was saying, this leads me to believe that they are probably coming from the same factory. The temperature regulation and temperature measurement accuracy seems to be a bit better on the STM32 station. I haven't done any data logging, just my general feel while using it. Also, the STM32 OLED station seems to have better temperature regulation and seems to measure temperature more accurately. The vibration switch inside the handle of this station is nicer. It has a higher sensitivity, detecting a touch of the handle immediately. So I will have to change the vibration switch that I have on the STM32 OLED station. I think it lacks some functionality like calibrating the temperature through software or easy adjustment of the standby time or delay. Or maybe it's just that I haven't figured out how to change those settings yet. I found some information on the internet that for this STC based controller there should be a menu with options from P1 up to P11, but in my case, if I press the menu key, I only have menus from I only have P10 and P11 menus, so just two menus. P10 is the rotary encoder step size, and I was able to change that, but I haven't figured how to adjust, for example, the automatic shutdown time. It doesn't appear to let me access that menu. The stand, although useful, is not very nice. You do need a place to rest the hot handle, but it just doesn't have the correct size. As you can see, the tip touches the end of the stand, and I don't like that. The kit also, as shown in the video, does not provide a ground connection, and that's pretty important, but I've shown you how you can fix that. The power supply seems to be perfectly capable for this job. After using the soldering station for about 30 minutes, I measured the heatsink temperature and it was roughly 45 degrees Celsius, so it shouldn't have any thermal issues. That was all for today. Don't forget to check the links I've placed in the description below. If you enjoyed the video, don't forget to like and subscribe to my channel, and I will see you next time.